Hey everyone, my name is Alex. I'm a student at Towson University. This is for the application software security course. And what I'm going to demonstrate is a web application that properly sanitizes and validates user input on the fly to prevent SQL injection. So what is SQL injection? SQL injection is a way that a malicious user could obtain data that they shouldn't have access to, or a way to tamper with data, or a way to just delete data in general, which could be, potentially very expensive for companies to lose, precious data. So the way I'm going to kind of explain our project is kind of from the back end to the front, just to kind of give you an idea of all the underlying pieces that work together to make the entire application functional. So I'm going to start with our database. We have a local instance of MySQL running on our machine, so you can see it's running. And we have randomly generated people records. And I can kind of show you what that looks like. So here it is. We have, I think it's roughly 1,000 records of people in our database, and you can see, each record has various properties like first name, last name, email, etc. So this is our database. Nothing really fancy going on. The second piece of our project involves a Java REST API. So what is a REST API? Basically, it is a service that allows various systems to communicate via HTTP. So that's kind of, in our setup, our user interface interacts with a REST API, which we wrote in Java, and it communicates via HTTP, like gets and posts, and that API in turn interacts with the database. So all the communication is going between the REST API and the database. So I can kind of show you what that REST API looks like. So I'm going to move very slowly towards the front. So here is kind of so we use Spring MVC, which is a Java model view controller framework, and it makes it very easy to communicate with databases. So we can see here in the code we extend this CRUD repository, which is create, read, update, delete, to interface with the database. And really not much code needs to go on because the Spring framework allows it to be very easy. So before we get to any of the SQL injection stuff, I just kind of want to explain how everything works. So we can find by ID, find by username, last name, email. We can just by defining these methods, Spring takes care of the implementation of that. So it kind of magically does all this stuff for you. For example, if you give this method an email, it'll search the database, for the given email here. So that's pretty neat. So that's how the API interacts with the database. So how does the user interface, the website, how does that interact with this Java API that in turn interacts with the database? So this is kind of like our portal, right? So this class right here is a controller that kind of controls the communication between the user interface and the database. So this is kind of our portal for communication. So we define all these endpoints, get by first name, get by last name, get by email, etc. So basically all the properties that a person has. And we just query the database, which is represented in this repository object, with the given string that the website's going to give to the REST API. So let's see. So we also use this technology called Swagger, which takes any given I guess Spring API definition and provides a nice, like, I guess, user interface. So I'll show you what that looks like. Well, first I should probably start the application. So here's our application. This is where everything runs out of. This serves the API and the actual web user interface itself, which I'll get to in just a minute. I believe it's running. Actually, it is already running. So it's already running, so I can go ahead and show it to you now. So this is just a visual representation of our REST API. So, for example, our web application, when a user types in when a user types in a search query, for example, they want to search by ID 6, this is actually what they're going to. They're going to send a request here, and this is the response that the API is going to return back to the web application. So now let me show you the web application. Let's see. So here is the web app. Basically all it does is it pulls in, it starts off by pulling in all the records from the database, and it paginates them nicely here. You can go to any number of pages that you would like to go to see the data. But I guess this is kind of where we implement our SQL injection detection, is in the search bar. So just to kind of show you how it works, so you can search by any number of these filters here. And for example, we'll search by China, and when I press enter, you can see we get all the records of people that are from China. So, for example, in our website, when a user types in China, presses enter, what they're really doing is sending a request to our API to this get by country endpoint. So they enter in, they send China here, and this is the response that the API sends back to the web page and allows it to display all these records. Okay, so this is our web application. That's all it does. We have a simple search feature that allows you to filter results via this search bar and these categories. Okay, so how does this web application prevent SQL injection from happening? So, excuse me. So we, in addition to our find by methods in our API, in addition to for retrieving people, we also have a hidden validation endpoint. So what this endpoint does is for every keystroke that occurs, so for every single time a character is typed, for example, I typed in 5 characters, so what actually goes on underneath the hood is 5 separate validation calls are made to our validation service. And I can kind of show you that in action by opening up. So if we take a look at the live HTTP headers, I can kind of show you what's going on underneath the hood. So let me refresh our page here so you can get a fresh list of calls here. So you can see our network, when the application first loads, it makes a call to /API/person/getAllPeople, and that's where it gets all these records from. So I'm going to go ahead and do our same query to China, right? And you can kind of see over on the right hand side here all these requests that our web application is making. It's sending every single keystroke to the validation service. So we can crack these open and you can see that the response on all of these is true. So in our design, we return true if the search query is valid, if there's no SQL injection detected. Um, and you can kind of see, if suppose we start to enter in some SQL, then we'll see a different response. So let me start off. I'll type in select. So just to kind of go along here, you can see, each keystroke is being sent to our validation service, and we're returning true. But then when we get to select, which is a SQL keyword, we now return false. And suppose I tried to, if I want the select star from, this means I would have to know the name of the table, but suppose I try to type in this query and press enter. Our web server or our website says, potential SQL injection detected, query is not submitted. And that's because we have, this is a SQL command. So we're not going to allow a user to inject potentially harmful SQL and get executed against our database. So, if I drop mock data, which is the name of our table, and do a search, that's not going to allow me to do that, which is really nice. So you can see, all the requests here on the right-hand side that are being made every time for every single key up event, which is our website is listening for. A validation request is made to our validation service. So what's going on in our validation service? So let's see, where is it? So here's our SQL injection service that actually does the validation. And really, it's nothing more than 3 regular expressions. Regular expressions are it's kind of like a computer science standard for detecting patterns in text. So, all we have is a simple validate method that takes in the query, which is the given text at the time as the user is typing, and it runs that query against these 3 different types of regular expressions. So, our first one we check for are apostrophes. So if we detect single quote or double quotes, we're not going to allow that query to go through the system. The other one we check for is semicolon. That usually indicates the end of a SQL injection query. And the last one we do is check all the major keywords in SQL. So alter, create, delete, drop, insert, merge, etc. So if the query finds, or if our query matches any of these patterns, we're going to return false and not allow the user to submit that query. Otherwise, if it passes the test, we return true and allow the user to execute that query against the database. So, yeah, that's pretty much it. We essentially, all we do really is sanitize the input on the fly. So I guess one last piece I could go over is how are we doing that on the fly? So for example, how are we, as I type in keys here, how are all these requests getting sent? So we use, so in our this is the web piece. This is the HTML, CSS, and JavaScript. So what we actually do, so let me see if I can find where that is. So there should be okay. So here we actually wrote a custom directive using Angular.js, which is a JavaScript framework published by Google. So this validate directive, which I'll go find it. It's right here. Okay. So what this function does is it listens for the key up event, which is when the user is typing. So every single key up event, we're going to call this validate input method and pass the input text to that method. And that method's defined here in also in JavaScript. And this is kind of where we send that GET request to our validation service API. That's our Java API. As you can see, it goes to validate, and then query equals, and that's where we submit the text. It gets sent to, essentially gets sent to this page, right? And gets sent. Our service returns false, and then this message gets displayed to the user. So yeah, that's pretty much it. So we successfully made a web application. It detects SQL injection queries on the fly by making AJAX calls to a validation service that we created on every single keystroke in our text box field. And what this does is protect our database from being tampered with by any potential malicious user. So they can't go in here, modify records. They can't go in here and potentially drop our database, or they can't go in and get personal information of any particular users. So yep, that's what we've done. We made a web application that sanitizes input for SQL injection. All right, I guess that's it. I guess if you have any questions, you can send me an email. All right, thanks.